it's been a pleasure to work with Daniel and team on a project right now with the California Department of Toxic Substances Control on incentives for safer chemistry and for cleaning up contaminated sites and toxics reduction. Obviously, there's a lot of fantastic work happening in Sweden around chemical substitution, safer chemicals, from the work of FRAM to ChemSec to the Swedish Substitution Center to the work of Chemi. So I hope I can add a little bit here to the discussions that are already having. And as Daniel said, please use the chat, raise questions, throw in reports, etc. That'll be, I'd like to make this interactive. So just to give you some background of where I'm coming from, I work with a number of centers and activities ranging from basic research at the university to working with companies through our Toxics Use Reduction Institute, which is established under Massachusetts law requiring manufacturing firms to evaluate toxics reduction options. I'll talk about that. From the Green Chemistry and Commerce Council, which is a supply chain group that we created of businesses across the value chain trying to accelerate better chemistry, to the Association for the Advancement of Alternatives Assessment, which is a multidisciplinary professional network trying to advance the fields of alternatives assessment for informed substitution. So here's the overview of what I'll try to get through in a fairly short time. I'm not going to spend a lot of time on the drivers for safer chemistry, but really talk about how we're thinking about addressing those challenges through science, policy, and market transformations, and some of the lessons learned about strategy in that. I won't spend a lot of time because I think we all know the drivers of safer chemicals or green and sustainable chemistry: legislation, market demand, consumer advocacy, and then the evolution of science on the problems and the solutions. And then this global recognition around sustainable development goals and the circular economy all have a role to play. Certainly legislation, there's a whole literature on this, that policy is a key driver of innovation and in safer chemicals. We have policies in Europe, we have policies at the state level in the United States. Federal policy in the US is a little bit slower and not as proactive in driving markets. Certainly the Green Deal and the chemical strategy for sustainability will take that even to a higher level, of really pushing the policy market, which will be critical to drive better chemistry. The chemical strategy, which is still being developed, the REACH revisions, the idea of essential uses, the generic risk management approach in the chemical strategy, all of those will have a very strong push effect on driving out bad problem chemistry, but also pulling better chemistry. And we'll talk about that in a little bit, how to design smart policy around that. Obviously, increasing media attention and consumer NGO attention. ChemSec's made these wonderful videos about problem chemicals and the rap battles, and that really popularizes and makes this hit home to consumers and certainly retailers as well. The global plastics crisis is very visible. NGOs like ChemSec have new tools and strategies, and they're empowering consumers to ask questions. And certainly this increased pressure on brands and retailers to act is very key. In the US, there's a campaign called Mind the Store, which is evaluating retailers on their chemical strategies, and retailers are acting in response to the very public campaigning to say you're not doing enough to address chemicals of concern in their products. ChemSec's ChemScore is doing this with the chemical industry, but really engaging the investment sector to say, hey, chemical industry, you can't be sustainable if you keep on manufacturing substances of very high concern, and you need to increase your investments in green chemistry solutions. So retailers are responding. Target, one of the largest retailers in the US, is pushing forward the idea that they're getting a good grade on the chemical scorecard because they are responding to consumer pressure. Walmart, one of the largest retailers, the second largest in the world after Amazon, has established a sustainable chemistry program in response to both internal drivers but external drivers as well. And there are metrics coming about to help do this, measure action in the marketplace. So the Chemical Footprint Project is an NGO initiative to provide a metric like the carbon footprint for how companies are doing in their chemicals management and driving safer chemicals. But we see campaigns in other sectors as well. I see H&M is on the phone, on the call. So campaigns like the Greenpeace Detox campaign, campaigns like Healthcare Without Harm, or the Clean Electronics Production Network, or the Healthy Building Network are pushing specific sectors, whether it be building, footwear and apparel, electronics, healthcare, to really not only focus on climate, but to focus on the chemical ingredients and the products they're manufacturing. So a focus really on better information about chemical ingredients, but also to get away from problem chemicals. And I think the ZDHC in the footwear and apparel industry is one of the best examples of how advocacy campaigns can mobilize a whole sector to change its ways from manufacturing through products. There's also science drivers, right? The science of chemicals is evolving. We're learning much more about how chemicals are dangerous to both health and ecosystems. We're doing more data on chemicals in the environment, finding them in both ecosystems and in humans. And we're learning much more about the links between chemical exposures and a range of diseases. There are about 180 different illnesses that have been linked to chemical exposures. And our toxicology tools are increasing our ability to detect those problems. But then there's the whole issue of consumer drivers, right? Younger shoppers want safer, more sustainable products. They care about their health. There are new tools for consumers to be able to understand chemicals in products and understand which ones might be safer. And then these global themes like the UN Sustainable Development Goals, and certain ones relate to chemicals, but the whole idea of the circular economy and the Ellen MacArthur Foundation really elevated that. You can't have a circular economy if there are toxics circulating in that economy. So this idea of a safe and circular economy is quite important as well. And then lastly, the data we have on chemical exposures and impacts. So the Global Chemicals Outlook, which is the United Nations effort to really understand chemical impacts globally, really found that the global goal to minimize adverse effects of chemicals and waste will not be achieved, right? So we really need to be both addressing chemicals of concern and driving better chemistry. And then lastly, new research just published about a month ago identifies that, or 2 months ago, that identifies that chemical pollution is exceeding planetary boundaries, right? We're crossing a point of no return with chemical pollution. And the Economist Impact just did a similar report called Back to Blue, or the Invisible Wave, really looking at ocean pollution and that issue of ocean toxics pollution and that issue of planetary boundaries. Obviously, we have plenty of experience and plenty of examples. The European Environment Agency's late lessons from early warnings really indicates that when we don't act on early warnings, we run the risk of having irreversible damage to health and the environment. We've seen that from asbestos, PCBs. We're seeing it now with PFAS. So let me stop here and ask this question of all of you, right? There's a lot of science on problems. It's, I've been studying the health effects of chemicals for 25 years or almost 30 years. The science is only getting more problematic, more concerning. We've had those early warnings, and there are lots of drivers for safer chemicals, but then why isn't this the norm? Why are we still fighting chemical by chemical to eliminate those chemicals or drive better chemistry? So throw some ideas into the chat. Why are we still in this reactive mode rather than saying we need to do something quick? Business models based on growth. So, yeah. Other thoughts on why we're, despite all these signals, why are safer chemicals just the norm, the mainstream? We're still redefining what safe means continuously, right? We're not completely clear as to what that means, and we're now doing that. It's cheaper not to pay for damages. It's easier to go on than to change. Yep. Good. Yeah, a whole set of factors. Policy takes time. That's clear. Good, good. So let me just forward on and focus on new products first, environment second. I think that's true, and we're going to have to change the way we do chemistry. That performance and cost were the intersection of the main drivers of chemicals development. We need to make environment, health, and safety another performance factors in the design of all chemicals. So good, excellent. So let me just talk a little bit about the challenges, right? Our approach is still quite reactive, right? We have a system that is often lacking in information. That's changing with policies like REACH, with better supply chain information flows, but it's still not perfect. It's a very reactionary system, right? We never designed the vast majority of the chemicals on the market today by volume were designed without any consideration of environment, health, and safety. That wasn't an issue when they were designed in the 60s or the 50s or even the 70s. It's resource and time intensive to go chemical by chemical, assessment by assessment. Risk management tends to focus on avoiding harm rather than driving better. And it's very disjointed, right? Chemists aren't talking with health scientists. Engineers aren't talking with health scientists. We have agencies that fund research on chemistry not talking with regulators. So we haven't really linked innovation to the regulatory agenda. And we have an investment community that continues to fund the status quo, right? They make money on ethylene and polyethylene and the incumbent chemistries, and their investment times that are long scale to develop new chemicals. We'll talk about that in a minute. And the chemical enterprise itself is built on fairly unsustainable foundations of large-scale reactors, a small number of platform chemicals, high energy intensity, and switching that fundamental underlying foundation of the chemical enterprise will be very challenging. So here's an example from our work looking at the limits of the current approach. We took a look at the growth of articles on BPA dating back to the 40s. Until about 2000, there were only 50 or 60 articles on the toxicity of bisphenol A in the literature. After 2000, it jumped into the hundreds. And if you looked at the research, even those who said BPA is the safest chemical and those who said it was the worst chemical on the planet, their answers were still, we need more research, right? And all of the work was focused on studying the problem rather than finding solutions, right? And when we focus on studying problems, we open the door to unending debates over mechanisms of action, scientific panels, and that leads to inaction, because while we're studying problems, we tend to focus on not doing anything about them rather than finding better options. And when we don't do that, we get regrettable substitution. So by focusing on getting rid of BPA, we ended up with bisphenol S. By focusing on getting rid of some of the methylene chloride, we ended up with N-propyl bromide, which is a neurotoxicant, worse than methylene chloride. By focusing on getting rid of PBB flame retardants, we ended up with other worse flame retardants because we didn't think about what we were switching to. We focused on long debates over the harm, and then we said, get rid of it, without saying, what are we going to? I think Daniel's work really shows this quite well, and he mentioned that the work is now going to be published in the Journal of Cleaner Production. So, risk of trichloroethylene, we've known for 30 years that it's potentially carcinogenic. In the United States, it's one of the most widely found chemicals in hazardous waste sites. In Massachusetts, we said we need to get rid of it. We need to find safer alternatives. So we worked with companies to find better alternatives that were safer and that worked in particular applications like metal finishing. And we reduced the use of trichloroethylene by 95%. We saved industry millions of dollars because it costs money to have insurance, to do hazardous waste treatment and storage and then shipping. And yet EPA is not even finished with its risk management plan for trichloroethylene after almost 20 years of risk assessment and debates over the mechanisms of toxicity of trichloroethylene. Yet ECHA went to issue an authorization for trichloroethylene and didn't focus on what companies were switching to. And they a lot of them switched to perchloroethylene, which we see as a regrettable substitute. So if we focus on the problem, we don't think about what people are substituting to, and we also spend endless time debating the nuances of the risk, which takes years. And, I can fight anyone on any risk, and end up debating it forever. So the National Academy of Sciences in the US said, basically we spend too much time on problem identification, and we don't spend enough time using our scientific tools to develop safer technologies and solutions. So we really need to spend equal time finding solutions as we do studying problems. So we think about this change of moving towards safer chemicals in 3 ways, right? A science transformation, a policy transformation, and a market transformation. I'm going to talk about those in 3 ways that we've been doing this. The first is talking about alternatives assessment. And one of my mentors wrote a wonderful book called Making Better Environmental Decisions, an alternative to risk assessment. Mary O'Brien noted that one of the most essential and powerful steps to change is understanding there are alternatives. So the National Academy of Sciences in the US did a framework book, much like its red book on risk assessment, but for alternatives assessment, where they define the field as a process for identifying, comparing, and selecting safer alternatives to chemicals based on hazards, comparative exposure, performance, and economic viability. And they made it really clear that alternatives assessment comes in when you have a decision to substitute. It's a process for identifying the best options based on a careful evaluation of pros and cons of those options. And the goal is not to assure whether a particular chemical is dangerous or whether a risk level is safe, but really to find the best and safest options. And the goal here is informed substitution, right? That we really think about that transition from a chemical of concern to safer chemicals using the best available information, and with the goal of minimizing the likelihood of unintended consequences. We don't have perfect information, so we need the best available information to make those changes happen. So when we think about alternatives, we really think about a step-defined process, but the starting point being really about the function of the chemical, right? The chemical serves a purpose, it has a function. And when we think about function, we can think about whether that function is necessary or essential. For example, is flame retardancy necessary in a sofa? Well, we found out that flame retardancy isn't necessary, or you can achieve that function in a different way. So we think about how do we achieve that function in a safer and more effective way if that function is needed. And then finding an alternative and getting industry to adopt it are very different, right? It must be affordable, it must be effective, it must be feasible. And in some cases, we don't have better alternatives and we need to develop them. So we coined a phrase called functional substitution that really looks at this in a broader way. So if we're thinking about BPA and thermal paper as a developer, you might think about a change in the chemical to develop the printing, the image. You might think about a different way of printing, or you might think about a different way to provide the function of that chemical, which is documentation, or that product, which is documentation. So electronic receipts may do just as well. There are 3 steps to this approach, right? Identifying a wide range of alternatives, chemical, non-chemical, presentation of the potential adverse effects of the options, and then the benefits of the options at its simplest, right? It gets more complicated, that the National Academy has a long list of 9 steps, but it's really about defining the goals, understanding that chemical of concern, identifying alternatives, comparing their hazards and exposure trade-offs and cost, performance, and life cycle trade-offs, and then selecting that alternative, and then implementing the alternative, because at the implementation phase, you may see impacts that you hadn't thought about. And we've written about this. This is a table from an article we wrote in 2018 that identified the the different steps of alternatives assessment, and what happens at each of those steps. But there are research needs, and this is where researchers come in quite effectively, right? We know there are still gaps in our science. We need improved hazard assessment approaches. We need improved ways to understand comparative exposure trade-offs between alternatives, right? We're looking at not at exposure in the context of controlled exposure, but intrinsic exposure that might be caused by bioavailability or persistence or mobility. We need easier ways to evaluate and compare life cycle trade-offs, because companies now are not only thinking about toxicity, they're thinking about circularity, they're thinking about climate impact, they're thinking about water impact. So how do we bring those all together to evaluate in an effective way that doesn't lead to paralysis by analysis? We need better ways to evaluate the full life cycle costs and benefits, because this is often one of the most common reasons for not substituting. Either it doesn't perform sufficiently or adequately, or it costs more. So how do we look at this in a more holistic way to understand not only the direct costs, but the life cycle costs, as well as the externalized costs when we're doing economic analysis of alternatives? And then finally, decision analysis. When we're dealing with multiple attributes, how do we really think about those trade-offs in an open and transparent way, so we're clear about what we're trading off? There's no perfect option, right? And there's always going to be some trade-off. And when we identify and are transparent about those trade-offs, we can think about the interventions to minimize those. For example, if there's added energy in the production of an alternative, how do we reduce that energy intensity of the alternative? There's a whole set of work of how to take the information from alternatives assessment and use some of these new biological and toxicological tools of in silico or high throughput methods to design safer chemicals. And this is where the academic community can be very helpful. Of how do we take all this new information about how to assess toxicity and apply it to designing safer chemicals? There's a lot of information out there that we need to do a better job to remove data gaps in our understanding about chemical toxicity, particularly for new chemicals that don't have lots of data. And when we don't have that information, for example, on carbon nanotubes, we might end up with regrettable substitutes. So how do we use some of these new tools when we're doing alternatives assessment to minimize regrettable substitutes? In fact, multi-walled carbon nanotubes are an alternative for PFAS. Well, how do we evaluate them when there are limited data on their hazards? How do we use some of these tools of new approach methods in toxicology to design safer nanomaterials? So here are some of the parts where these new assessment methods, these new toxicological methods, can be very helpful to identifying and developing safer alternatives. And prioritizing and understanding red flags. So you're designing a new chemical. Using the tools of toxicology, you can identify red flags and say, we're not going any further with this chemical. So grouping to avoid regrettable substitutes, where we identify a group of chemicals with similar structures that we might want to avoid as a whole as substitutes. But also having design criteria for new chemicals. So how do we take the knowledge from alternatives assessment, from toxicology, and apply that to the design of new chemicals? And there's a whole area of this called rational design. So linking, again, the interdisciplinarity of understanding toxicology and taking that knowledge to design safer alternatives. And one good example is an alternative that was designed by Valspar as a BPA alternative in can coating, using the tools of toxicology to actually design out the endocrine disrupting part of the bisphenol molecule to design a safer alternative. And there's a whole literature on this. We have an article looking at this question with both the Valpure and a solvent designed by Eastman Chemical, using principles of alternatives assessment and green chemistry to design safer chemicals. So we're trying to build this interdisciplinary field. So we've created a professional society to connect to other professional societies, because we need an ability to link science and practice around alternatives assessment. And we've created the Association for the Advancement of Alternatives Assessment to do that, to create a community of practice around safer chemicals, around substitution, around the science of toxicology and risk assessment really being used to not define safe chemicals, but to define and help support safer chemicals. So let me talk for a minute about how we think about this at the application phase through the Massachusetts Toxics Use Reduction Program. Massachusetts has a law called the Toxics Use Reduction Act, which was established in 1989. It requires manufacturing firms in the state to both understand their chemical use and undertake every 2 years a prevention planning or a toxics use reduction plan to evaluate alternatives that would reduce their toxics use and waste generation. They pay a fee on chemicals that supports both the regulatory program, but also a voluntary technical support program and a research and education program at UMass Lowell called the Toxics Use Reduction Institute, which does research, evaluates alternatives, does funds research, and then does education and training. Let me give you a couple of examples of how we do that, right? We identify and we prioritize higher hazard substances in the state. We train experts who have to certify these plans on the tools of chemical hazard performance and cost assessment. We do assessments of alternatives to common uses of toxic chemicals, and then we fund research to evaluate and develop safer, effective, and affordable alternatives. So let me give you one example, perchloroethylene, which is used in garment cleaning and vapor degreasing. It's a carcinogen, it's a neurotoxicant, and it causes reproductive damage. So what we did was we started working with small dry cleaners to identify alternatives and evaluate those alternatives from a toxicological cost and performance level. And what we did was then present this information in an easily digestible way back to users to say, what are the better options to perchloroethylene compared to the incumbent? What are the better options? And then what we can do is, and wet cleaning seemed to be the best, what we can do then is work with dry cleaners to help them convert their operations to wet cleaning through demonstration, right? We find ones that have already done this. And when we work with those, we have them demonstrate to their peers, what are the better alternatives? How do they work? And they show that they work so that it de-risks the adoption of the safer alternatives. And then we provide grants to dry cleaners to help them convert their operations to safer alternatives as well. Hexavalent chromium is another one we're working on. We're working with the aerospace industry to help them find alternatives to hexavalent chromium in corrosion-resistant coatings. We have a large aerospace sector in Massachusetts. Hexavalent chromium is a carcinogen. So what we try to do is look at compliant applications that'll meet military standards, and then see how we find safer alternatives to do that. We bring together actors in the supply chain of the aerospace industry to actually evaluate the alternatives in their own facilities so that we can show that those work, right? It's pre-competitive, bring together competitors to solve a mutual problem they all have and see how we find the better alternatives that actually work. So we do actually testing on their own equipment and in pilot testing. We evaluate the hazards of the alternatives, and then we support the adoption of those in the marketplace. So what we've done in Massachusetts is really find higher hazard chemicals, identify where there are multiple users or similar processes across sectors, where there's a pain point, where we can then work with companies to evaluate performance hazards and costs, and then develop information appropriate for audiences so that then they can go and apply that information to make effective changes. So let me then jump into green chemistry, right? We see a whole set of thriving world of green chemistry. It's growing, the community is growing. And we see this ability to grow the field, but as I mentioned, it's still niche. There's still a lot of activity in academia and small startups around green chemistry, but the safer chemicals are not the norm. And the good news is the value is very clear of green chemistry. We did a business analysis last year that looked at point of sales data. It looked at industrial surveys and case studies, and it looked at macroeconomic jobs and modeling. And we found that, compared to incumbents in the same product category, chemicals that either have certifications or claims of safer chemicals are growing at 12 times the rate of the incumbents in the same product category. So the growth is very clear. The business case is very clear. So why aren't we doing it, right? What we've found is there's a number of barriers to green chemistry in the marketplace. Most of those relate to the incumbency of the existing chemicals, which are highly capitalized and optimized in complex supply chains. There's confusion about the definition of safer. There's concern about the risk of switching. What if the performance is unequal? What if the cost is more? What if no one's willing to pay? And there's not clear demand signals at times for those safer chemicals. And then sometimes government regulation works against those safer chemicals, making it harder to bring them into the market. We have these growth drivers, and we found that there are certain accelerators, collaboration, forcing of technology from large purchasers, for example, retailers, and then this need for compromise and education in the value chain. So this is where we built a network to try and solve that, to find the push-pull of the marketplace to drive safer chemicals. So we created the Green Chemistry and Commerce Council as a network of about 100 companies across the value chain, focused on really driving and accelerating the growth of green chemistry solutions, bridging the gap between the technology needs and the drivers and the solutions, because there's something in the middle of that demand and supply nexus that's creating barriers. How do we overcome those barriers, right? We might have really great green chemistries that have been developed, but they're not making the market. They're not growing to scale. Well, we need to address those barriers to scale. So we work with companies across the value chain, from major retailers to brands. We have 14 major retailers, we have brands, we have chemical suppliers, and innovative startups. And what we're trying to do is create a pressurized system of push-pull in the marketplace to really understand the barriers, but then help pull along the drivers as well. Our goal is really take the early adopters and make them, bring in the early majority, and then hopefully push and accelerate that curve of adoption and innovation that Everett Rogers spoke about so well in his book, Diffusion of Innovations. So we have three ways we do this: through engaging the value chain to both understand challenges and success stories. We bring together companies to find ways to collaboratively drive innovation and commercialization, and we do policy advocacy around solutions. So, as I mentioned, we have a group of 14 now major retailers that are both sharing their strategies around safer chemicals. They're putting out statements of where they want to have, creating innovation, so creating strong demand signals, and then really building understanding with downstream, upstream partners, brands, and then retailers. What are the barriers? We convened a group of chemical suppliers and retailers where the retailers thought that they just said, we want safer and we get it overnight. They didn't understand that chemical innovation cycles are 8 to 10 years, especially if it's a new chemical, 3 to 7 years if it's reorienting a chemical, the reformulation phases, the recertification phases, the regulatory approval phases all take time. The chemical suppliers didn't understand the types of consumer pressures to develop and source safer chemicals that retailers are under. So we've done a number of projects to try and build understanding around chemical transparency, around innovation between retailers, brands, and chemical suppliers. And these are some of the priorities our retailers actually are updating today to say, where do we want to have change? What types of chemicals are we concerned about? And what kinds of chemical functions do we want to have better options for? So there's a clear demand signal into the marketplace. The chemical suppliers have said to the retailers, don't tell us what you're against, tell us where you want to have innovation. But that also means that the retailers are willing to pay more because capitalization, reformulation, all of that costs money. And that's the kind of pressure and discussion we're having within the GC3. And we've done a number of projects to understand barriers to innovation and then how we overcome them. We've done this on plasticizers. We've done it on preservatives in personal care and household products. We're working on cyclic siloxanes right now. So really trying to understand those needs as well as the solutions and the accelerators of green chemistry solutions. So one of our most successful projects was bringing together 2 retailers, 11 brands, and 6 chemical suppliers who had a pain point around safe and effective preservatives in consumer products. We developed a set of criteria for safe and effective preservatives that, we had brands ranging from the greenest of the green to Procter & Gamble. And what that did was it pushed the innovation to a more, what I would say, progressive or precautionary way, because the greener brands really wanted it to meet their specifications. They said, we need it for everyone. So that pushed the innovation accelerator. We then did an open innovation challenge, identified a set of innovative preservative options that were early stage and later stage, and then we did a pitch event. What ended up happening was we brought all the suppliers, the innovators, and the sponsors together, but nothing happened, right? There were still too many barriers in the value chain for new preservatives to enter the market. So what we've done now is we're trying to understand what those barriers are and then find later stage options and try to address those barriers, some of which relate to market segmentation, some of them relate to regulatory burdens for new preservatives entry, some of them relate to just having sufficient scale. We work on also policy incentives. So we have a policy alliance in Washington that got a law passed on sustainable chemistry to create a federal activity or federal coordinated activity around sustainable chemistry in the US. We've been working with agencies like the Department of Energy to put sustainable chemistry innovation into its priorities around climate change, for example. These are how we're trying to think about the definition. I saw that as one of the barriers is a definition, right? Being clear about what our definitions are. This is a definition we've been using in Washington for sustainable chemistry. We have another project with multiple stakeholders, including H&M, which is on the phone, to develop a broader stakeholder definition and criteria for sustainable chemistry. And this feeds nicely into work happening in Europe around the safe and sustainable by design approach and the criteria that the European Commission is developing that focus not only on design, but how we assess chemicals that are safe and sustainable. What are the criteria so that there's clear signals into the marketplace around what is better, but there's sufficient flexibility that we're making progressive improvement and not hoping for perfection. Perfection is the enemy of the good. So trying to go forward in a progressive direction without expecting that we're going to have perfect overnight. So here's how we're thinking about it, and then I'll wrap up, is really thinking about all of this work in the GC3 being linked back to research and strategy at the university. So really thinking about the innovation strategy, right? Bringing together stakeholders along the value chain in collaboration, bringing in policy incentives, upping this to the C-suite of companies, and then really thinking about strategy for commercialization. And then addressing some of these big barriers, which I'll skip over. So let me first say that what we've learned is innovation isn't sufficient to drive commercialization. So we need to focus not only on new molecules, but how do we get them into the marketplace and scale. That what we've learned from the GC3 is that the chemical industry is part of the problem, but necessary to the solution. But so is the rest of the value chain part of the problem, because the value chain is buying those chemicals, integrating them into products, selling them. So the whole value chain is responsible for both the problem and the solution. Collaboration is critical to providing that amplified demand signal. And then having a broad range of companies from the most forward-looking to the traditional companies pushes that innovation accelerator, and that the challenges are very critical to address, and they're very specific, right, to individual cases. So we need to have strategies that address those challenges in each specific case, but there are some generic strategies that are important. So ultimately, if our goal is to grow safe and sustainable chemicals, right, we want to get rid of chemicals of concern. But if we don't have a supply of safe and sustainable chemicals, it's really hard to get rid of the chemicals of concern, right? One of the reasons we see sort of defense of existing chemicals is there aren't better options at scale, at sufficient scale and multiple suppliers that can replace the ones of concern. So it becomes hard if we don't have that supply, a diverse, broad supply of safe and sustainable chemicals. And thinking about that in policy, we need both the demand side policies, the restrictions, the information requirements, the purchasing policies, but we need also the pull policies, which are about assistance, information, R&D support, education, and the ones that create the opportunities for investment. So investment policies, tax policies, education policies. So as we think about policy, we need to have smart ones to design safer chemicals. And we need to think about these shifts quite effectively, right? So there are 5 key shifts we see in driving safer chemicals, right? We need to change policy. We're working on the first 3, change policy, change science, change markets, but we need to empower people to drive that change and then shift the narrative from chemicals are bad to we can do better chemistry, right? Better chemistry is possible and we can grow it. And we need action in these 3 areas to reduce chemicals of concern, both the supply and the demand for those chemicals. We need to grow safe and sustainable chemicals, and we need policies that drive their substitution. So growing the supply isn't sufficient because we need to support the substitution as well. So all 3 of those are really key. And as we think about it in a strategic framework in our work, this is how we're thinking about it, right? We have these tactics we apply of connecting people, lowering barriers, supporting champions, advancing understanding, emphasizing solutions. We work with the chemical supply chain, retailers and purchasers, policymakers, and the scientific community to drive these 3 shifts and hopefully to transition to sustainable chemistry and have healthy chemicals. That's where we're trying to get in our strategies. And I'll stop there and see what people think, and I can wrap up after that. So, here's the question I have, right? What do you see as the key strategic opportunities to grow our needs and opportunities to grow the supply of safe and effective chemicals and products? And I'll stop there.
Thank you, Joel. Thank you so much for this very rich presentation. You managed to cover a lot in a short time. You have received a few questions in the chat. Sverker, he asks about persistence. Why is that not addressed? Is it only toxicity?
I put persistence and comparative exposure, right? It's an intrinsic impact, right? So we need to address persistence by accumulation and now mobility. So how do we address, having chemicals that degrade more effectively, that don't persist, that don't bioaccumulate, and aren't mobile like PFAS in the environment? So yes, that is part of toxicity assessment. Mm-hmm.
Okay. And what about volumes?
That is a question, right? As we're thinking about alternatives, right, we might have a slightly less toxic alternative, but if it requires significantly more to achieve the same effect, well, we may be offsetting that. So that's where that comparative exposure issue comes in alternatives assessment. Are we needing a lot more to reach the same effect? And are we going to have similar toxicity? It's not doing a risk assessment, it's just understanding, is there a change? And what we've heard from some companies is if it requires 3 times as much to do it, we're not going to use it because it's going to cost us a lot more. So yes, we need to think about those volume changes as well.
What about the issue that Thomas Backhaus raises, that you have not as much information typically about alternatives? Can we improve the likelihood that the new and under-researched
Yeah.
chemicals is not worse.
Yeah, that's a big problem, right? We often have this misunderstanding in science that because something, I've heard this, I've worked on phthalates and I've heard this thousands of times, they've been studied for 40 years, that means they're safe. No, it just means they've been studied for 40 years. Just because something's been studied more doesn't mean it's safe. But companies tend to want to use the devil they know, right? If I've heard from formulated products companies, we'd rather use something that's slightly more dangerous, but we have good data, we know how to manage it well, than something we don't know anything about. And that's where these new assessment methods, these new tools in toxicology are really important, so that we can develop the information base quickly and effectively around these newer chemicals. I mean, one of the challenges as well is that newer chemicals like these safer preservatives, which on their surface, the design looks like they're safer, they face a roadblock, right? It's really hard to get a new chemical through, for example, the biocides process, in the US too. So there's only been one new preservative that's come on the market in the United States in the last 10 years for consumer products, because it's so hard. So that provides a disincentive to new chemicals innovation sometimes, because the information needs are so high. So we've been sort of discussing with regulators, if you have the data to be able to show that it is a safer option, safe and effective option, is there an expedited pathway into the market for those chemicals? Right now, what preservatives manufacturers are doing are calling their chemicals multifunctionals, not preservatives, but they're multifunctional. So they have a preservative function through some other functionality, for example, surfactant, so they don't have to go through biocides policies. But it's a big problem, and we need more science to be able to understand quickly chemical toxicity, so that we're not just substituting one problem for the next one.
May I just link to that issue a bit? Like for the biocides regulation and the plant protection regulation in Europe, you have the authorities doing the alternative assessment, if I'm correct, while for in REACH, it's those seeking authorization that needs to show that there are no alternatives. So the incentives are a bit different in these two, these different types of regulation. What is your opinion on what's the preferred model here?
Well, I think companies are the most, I think it's the way it's set up, right? You have to do the alternatives assessment for the continued use of that chemical. Of course, then you're going to do an assessment to show that there's no safer alternatives, because you don't have the time to actually do it, right? The companies that go into authorization have sort of put their head in the sand to some degree and not seen the writing on the wall that this is going to happen, and they're sort of stuck that they don't have better alternatives. So if you have to do that alternatives assessment, it's probably too late, and you're going to do an assessment that says there's no better alternatives. It's a disincentive, but I think companies do have the best information available to do an alternatives assessment. The question then is, can you have them third-party verified or some independent assessment? So in Massachusetts, the alternatives assessments, the toxic use reduction plans done by companies have to be certified by a third party. Well, not by a third party, but by a person who's undergone a 40-hour course, taken an exam. About half of them are within the existing companies. Half of them are external consultants. But there is an issue, that drives quality in the assessment, right? That if you're putting all the effort into the assessment, you're going to try and find options. The difference in Massachusetts is it's a planning process. It doesn't require that you adopt the alternatives. It just says do the assessment of alternatives. So, I think there's a combination between government and industry alternatives assessments. Perhaps for high concern chemicals that are used in a wide variety of sectors, government might do the initial alternatives assessment, where industry might do a follow-on assessment for their own operation to say, okay, of these potential options, which one works best for us? For example, US EPA did these comparative alternatives assessments on flame retardants, and then individual companies like HP went and did their own for their own product, like which one would work best for us.
So I've seen the question here by Adama, but I'll take Thomas' questions first here because it links to what you ended with there. Do you have any more general kind of view on the role of regulation or authorities in the move towards increased use of more sustainable chemicals?
Yeah, I mean, certainly the role of government policy to send clear signals to the marketplace of what to avoid is really key. So restrictions, but I think that needs to be linked, and that's what we've been talking over the years. We did work for ECHA on their substitution strategy, but then that has to be linked to the regulatory agenda, to our research and innovation agenda. So there needs to be a connection between what we're moving away from and what we're moving towards. And those don't tend to be in practice connected well. And it looks like in the chemical strategy, they're trying to do that more effectively. But then the other part of that we've been talking with the Commission about is there a way to support and fund a network of centers like the Swedish Substitution Center around Europe that then link the regulatory priorities to support demonstration, industry collaboration around driving safer solutions. So I think and then the last part is there needs to be investment. I mean, governments need to put investment. Right now, the US is subsidizing the fossil fuel industry at $20 billion a year. If you take the externalities, it's about $650 billion a year. Imagine if that money was spent on designing, commercializing, and scaling safer chemicals, right? That's how we built the chemical industry, was massive investment and supply chain collaboration and clear demand signals, purchasing signals from government. That's how we build the solutions. The last part, I think that government plays a key role is in recognizing and supporting safer chemicals. And European countries have been a little bit less supportive of that, but a key driver in the US of safer chemicals and consumer products is the US EPA Safer Choice Program, which is an eco-label program for chemicals, products that have safer chemicals in them. But what EPA is doing is giving a signal to the marketplace of safer chemicals and safer products. And that program is widely supported by NGOs, by formulated products companies, and by chemical manufacturers that have the safer alternatives, because they're getting recognition in the marketplace. So I think there's a whole set of ways that policy can better incentivize as well.
So the final question then from Adama is on global harmonization. Yeah. Also when a common alternative, if you don't get authorization in REACH, is that you need to move. At least is what company states in their applications, like you move to somewhere where you can use the chemical, and then it ends up in the product or anyway or somehow. So how do you view that?
Yeah, given that the chemical industry is and production are slated to grow the most in Asia and Middle East, we need a global approach, because otherwise it puts the countries that are doing, and I think Sweden's been very clear about this for years, right? We can do all we want internally to develop safer chemicals and work on safer products, but if we keep on having a fountain of those chemicals ending up in the environment in other places, and then it ends up in air currents, water, food, coming back to Sweden, we haven't solved our problem fully. So there needs to be a global approach. For example, through OECD. OECD is doing a lot of work right now on sustainable plastics and on safer alternatives. They're having a workshop in September through their risk management group on trying to develop global approaches to chemical substitution. So I think there is a need for global harmonization around safe and criteria for safe and sustainable, around tools and policies to drive safe and sustainable chemicals. Otherwise, we will see these disparities. And it also puts companies at a disadvantage. So we've spoken with some companies, for example, in the flame retardant space, that have the safer alternatives. A third of their market is China and Asia. Well, what they say is, we can't give up that market. We don't want to sell these chemicals, but if we stop selling them, we lose 30% of our market and someone else will fill that gap. So that provides a disincentive to industry as well.